All right, so let's do, now we're going to graph linear inequalities. It's extremely similar to graphing just regular lines, but there's a couple tweaks that we need to go over. So first of all, y is greater than or equal to negative 3x plus 4. When we start out graphing this line, we're going to pretend that we're still graphing just a regular line, that we're just looking at y equals negative 3x plus 4. In that case, we have a y-intercept at 4, and we have a slope of negative 3. So remember that we can change that into negative 3 over 1, which means we go down 3 and run 1, and there's our second point. So we can draw a line through that, and did not change colors. This line would look like this, because it is equals is still part of the function that we're graphing. So this is going to be a solid line. Now, since we're talking about y is greater than or equal to, there's a couple ways you can go about thinking about this. So for one, greater than or equal to kind of makes you think about like the upper half. So in this case, we are going to be shading in on the upper side of this line. Now, another way you can go about doing it is if you put in a point. Let's say if we put the point 0, 0 into this function. We get 0 is less than or equal to negative 3 times 0 plus 4, which is 0 is less than or equal to 4. Why did I change that sign? That is not a less than. It is a greater than. So let's try this again. 0 is greater than or equal to all that, and 0 is greater than or equal to 4. This is a false statement. So that tells us that we do not want to shade on this side of the line, and that we're still shading on this side. So that's one of the two ways you can figure it out, is just pick a point on either side of the line, put it into the function. If it's a true statement, you are shading on that side of the line. If it's a false statement, you're shading on the other side of the line. So let's do another one. Actually, let's do number 3. I want to skip number 3. So for number 3, we have y is greater than or equal to negative x minus 5. So first of all, we know that our y-intercept is negative 5. Second of all, our slope is negative. Well, why is it just negative? Why is there no number there? Well, there's actually a 1 hiding out there. Our slope for this one is going to be negative 1 over 1. So from our point, we go down 1, run 1. There's our second point. However, don't draw a line through this yet, because this function is not equal to. It is strictly greater than. So when we are drawing this line, we cannot draw a solid line because it does not equal. Equaling is not a part of the function. So when we draw this, it has to be a dotted line through these 2 points. That tells the reader or whoever's looking at these that this function does not equal the points on that line. Now again, it is everything greater than, so intuition tells us that we need to shade the top half of the function. If you want to try putting in points, again, try putting in 0, 0. I picked 0, 0 because it makes everything super easy, because it's really easy to figure out whether 0 is greater than negative 0 minus 5, and 0 is greater than negative 5. This is a true statement, so we are shading at the point 0, 0, which we have already done, because that is the upper half of the line, and we're talking about greater than. Fantastic. What's this problem? Ooh, I don't like it. Y is greater than negative 4. So this is y equals something. Y is greater than negative 4. So we have the y-intercept of negative 4, and that's really all the function tells us. But keeping in mind that this y is greater than negative 4 is that we're talking about all points where y is negative 4, which is everywhere on this horizontal line. Now, we want everything greater than negative 4, so we can just shade in above the line, because we're talking about the greater than portion. If you would like to use the origin way, if we put 0, 0 into this function where y equals 0, there's no spot for x, so that's fine. Is 0 greater than -4? Yes. Yes, it is. So where 0, 0 is, that is the correct side of the function. And now I want to do number 2. So y is less than or equal to 3/5 x minus 5. First of all, we have a y-intercept of -5, and we have a slope of 3/5. So that means we rise 3, run 5. There's our second point. So now we can draw a line through these, and it's going to be a solid line this time because y is less than or equal to. That equal to line under it tells us that is where we want to, or that tells us that we want to draw a line. And now, since we're talking about y is less than that, we want to shade below the line. So all that stuff. Or, if you want to put a point in, let's put in the point 0, 0. So 0 is less than or equal to 3/5 times 0 minus 5, which simplifies to 0 is less than or equal to -5. This is false, so we are going to be shading on the opposite side of the line, which we have done. Okay, this is where I pause. You work on the worksheet, and we'll go over that once you start playing this video again. Okay, so let's go over these. We did 1, 2, 3, and 4, which is great. Number 5, notice the dotted line that they're using because it is y is greater than 2x minus 5. It is not equal to. So we have -5 as the y-intercept and a slope of 2, which means we rise 2, run 1, which puts us at that point right there. Number 6, y is greater than or equal to 7/4 x plus 2, so we have a y-intercept of 2. And a slope of 7/4. Well, if we go up 7 and over 4, that takes us off the graph. So let's go down 7 and back 4, putting us right there. And again, as a review, the slope of 7/4 is the same as -7 over -4, because if you divide two negative numbers, you get a positive number. So those are the same thing. X is less than -5. Well, there is no top side or bottom side to this. So we have to think, if we're only concerned about the x values, if we want things that are less than -5, we want everything to the left of -5, which is why they shaded the left half before the dotted line, because it does not equal -5. For number 8, we have the y-intercept of -4 and the slope of 4/3, so we rise 4, run 3. Everything less than or equal to means they shaded the lower half. 9 and 10. Well, these are a little bit strange. These we need to change into slope-intercept form. And there's something tricky about these while doing it. So let me zoom in a bit. When solving inequalities for a variable, there's something important that you have to keep in mind. And we can look at this by talking about -2 is less than 1. This is a true statement. I hope you can see that. Now, what we can do is, if we divide both sides by -1, this now becomes 2 is less than -1. And now that's a false statement. So what we can say is when we have to divide by a negative number, and actually or multiply, when you divide or multiply by a negative number, that sign in between flips. So now, since we're dividing by -1, it's going to change to 2 is greater than -1. And that's going to come into play right now. So the first algebra step that we're going to do is subtract 3x from both sides, which gives us -2y is less than 10 minus 3x. Now when we divide both sides by -2, this changes to y is greater than -5 plus 3/2 x. And if you want, you can flip this around to be y is greater than 3/2 x minus 5. That puts it in more slope-intercept form. And we're going to use that idea for the next 3 problems. But anyway, this has a y-intercept of -5 and a slope of 3/2, so you rise 3, run 2. There's the second point. We're talking about greater than this time, so we're shading on the upper side of the function. For number 10, when we go about solving this, we get -3y is less than or equal to -15 minus 5x. Divide everything by -3, we get y is greater than or equal to 5 plus 5/3 x. So we have a y-intercept of 5 and a slope of 5/3. So I'm going to go down 5, back 3. Still keeping in mind when you divide two negatives, it's the same as positive because 5/3 is the same as -5 over -3. And now we're talking about greater than, so we're shading on the top half. Number 11 is set up fairly simply that we want everything greater than y being 4 or equal to, so it's a solid line. And so that's that one. Y for number 12, y is less than x minus 2. So again, this one, not again, but this one has a slope of 1. So we have a y-intercept 2, rise 1, run 1. That's kind of hard to say. So there's the second point. And now we're talking about y is less than x minus 2. So we're shading on the lower half of the function. All right, fantastic. Again, the link for this worksheet's in the description if you didn't get it already.